Okay, so right here on the class opener, it says that the coordinates of a function are solutions to that function, right? And we know that when we graph a line, we end up with an infinite amount of points, and those points represent the infinite amount of answers that exist to that equation or to that function. Right here on number 1 on this class opener, it says find 3 solutions to the function. So we have a function right here, y equals x minus 4 over 2, and they want us to find 3 solutions, and they want us to use an input-output table. What is that? What's an input-output table? Anybody?
Input, like the x, y.
Absolutely. An input-output table is an x-y table, where your inputs are your x values and your outputs are your y values. This is all a review from Algebra 1. Your inputs are your x's, so what you do is you input. What does that mean? You put in the number, whatever number you want, into the x, and then you work out the math and it'll give you the y. Okay, so the input are the x values that you put in to the x, and you do the math, and once you get an answer, that's going to be your output, which is the y. So what number would you like to plug in right here to the x? 0. Okay, 0 is a great number to plug in, and if we do plug in 0 right in here, I mean, you could show your work. I recommend you show your work, but we're going to do this in our heads right here. 0 take away 4. What's 0 take away 4? And what's negative 4 divided by 2? Negative 2. So when I plug in 0, I get out a negative 2. And that is a coordinate, that is a solution, right? That will be a true statement. What other number could I plug in?
4.
What was that?
4.
4? 4 is a great number. Why 4? Why not 1? Because if I did plug in a 1 right in here, 1 take away 4 would be negative 3, and negative 3 divided by 2 would be a negative 1.5, which is totally fine, right? But it's nicer to plug in numbers that give you nice outputs, that give you nice y values. So let's plug in a 4. That'll be a nice 4 take away 4, which is 0, and 0 divided by 2 is what? 0. How many points do we actually need to graph a line? 2 points, and we actually have 2 coordinates, 2 points, so we could actually graph it and we'll be done. 0, negative 2, 0 on the x. In case you forgot, 0 on the x, you stay here. Negative 2 on the y. Let's put a dot right there. So there it is, 0, negative 2. And then 4, 0, 4 on the x, 1, 2, 3, 4, 0 on the y. You don't go up or down, you stay there. 4, 0 is right on the x-axis. And we could draw a line through it, and that's it. We're done. Put some arrows on it. Now, I only have 2 dots here, but we know that there's an infinite amount of dots, an infinite amount of solutions. So like if I did plug in a 1, it wouldn't be as nice, right? If I plugged in a 1, plug in a 1 right there, it's going to be 1 take away 4, which would be negative 3. And then negative 3 divided by 2, like half of $3 is 1.5. So negative 3 divided by 2 is negative 1.5. And this is also a coordinate, and it does exist on that line. Check it out. If I go to the x value of 1, and then I go down negative 1.5, negative 1.5, I'll be right on that line. Okay? So the line really does represent every single solution that exists to an equation. And of course, we only need 2 points to actually graph a line. Again, that's all review, and we're not graphing today. What are we doing today? We are writing equations, and we're going to be learning 2 different forms. Actually, we should already know slope-intercept form. Okay? Why is this called slope-intercept form? Well, first of all, before we answer that, what is the word form? What does it mean? It's the shape, the way it looks, the appearance. Okay? So when I say slope-intercept form, if it looks like this, y equals mx plus b, you could clearly see the slope right here as your m value and the y-intercept, which is your b value. Let me repeat that. When it's in slope-intercept form, when you have y equals mx plus b, you'll be able to identify your slope just by looking at the number right in front of the x. And you'll be able to identify your y-intercept, where your line will cross the y-axis, just by looking at the b value right here. Okay? So slope-intercept form is really easy, and it's advantageous to use. Like for example, up here, instead of doing all this math of plugging in inputs and pulling out outputs, I could have made this look like slope-intercept form. It has the y equals, but it doesn't have a mx plus b. It has x minus 4 divided by 2. I could separate the division of 2 to both of those terms and write it as y equals, now there's an invisible 1 in front of the x, so I'd have 1 divided by 2 with an x, and I'd have minus 4 divided by 2. And now that's in slope-intercept form, y equals 1/2 x minus 2. And now I could clearly identify my slope and my y-intercept value. So if it's in slope-intercept form, now you could see where it crosses the y-axis. The b is -2. So I know that my y-axis, my line will cross this y-axis right at -2. Okay? And I also know that on this line, throughout the whole line, it's going to have this steepness, the slope of 1/2. That means that from one point to the next point, I'm going to go up 1 over 2. And then I could go up 1 over 2. So y equals mx plus b is great. We used it a lot in Algebra 1. If you don't know it from Algebra 1, that's not good, right? I mean, if anything in Algebra 1, you should remember y equals mx plus b. So if you don't remember it, let's understand it right now. And it gives you all these details about y equals mx plus b. Like we already know m is a slope. We already know it's rise over run. The b value is the y-intercept, where your line will cross the y-axis. If I give you a m and a b, you can write a linear equation. Let me give you an example of that. So I'm not going to show you a graph. I'm not even going to give you an equation. But let me describe a line. Let's say a line has the slope 1/2, and it crosses the y-axis at 5. Well, you could write the equation of that information. So what's the equation going to be? It's going to be y equals what? 1/2 x, and then plus 5. That's your slope-intercept form equation when I give you a m and a b. So we're going to be writing equations this whole lesson, all right? So I also might give you 2 points. And what did we do yesterday with 2 points? We found the slope using the formula, right? So if I give you 2 points, you could find the slope, and then once you have the slope, you could find your b value, then you could write your equation. That sounds kind of confusing, but I'll give you some examples. It'll be pretty easy. So let's jump up here to the top right part of our handout. There's some examples. There's 2 examples. Should have probably put space between this, but anyways, example number 1. The slope is 2/3 and the y-intercept is 4. Let's write the equation in slope-intercept form. What's that going to be? Y equals what? 2 over 3 x plus 4. The b value is 4. Perfect. Done. That's slope-intercept form. I wrote an equation given the information that they provided. Okay, now number 2 is a little bit more interesting. It's a little bit more fun, right? Number 2, it says that your line will pass through the coordinate 6, 9, and it has the slope 4. Okay, so could you write it in slope-intercept form? In order for you to be able to write it in slope-intercept form, you need the m value and you need a b value. Do they give you the m value? Yes, it's right here. Do they give you the b value? No, they don't. What do they give you? Coordinates. And what are coordinates? What is a coordinate? It's a y and an x, right? It's a point, right? An x and a y. Okay. So if you wanted to write the equation in slope-intercept form using slope-intercept form, well, you do it like in anything else in math. You take what they give you and you plug it in to find out what you don't know. So what do they give us? They gave us a y value of 9. So instead of y, I'm going to put a 9 right there. They gave us an m value of 4. Instead of m, I'm going to put a 4 right there. They gave us an x. I'm going to put a 6 right there. And the b, we don't know, but we'll have a bunch of numbers, which means we'll be able to solve for b. So let me rewrite this. Y equals, so that's going to be a 9 equals mx. M is 4 times x. What's x? X is 6. And then plus b. So I now have a bunch of numbers with one variable b, and now I'll be able to do the math and solve. So if I go 4 times 6, that's 24 plus b equals 9. And to get rid of the 24, I'd have to subtract 24 and subtract 24, thus giving me a final b value of -15. -15 equals b equals -15. And now that I know my slope, and now that I know my b value of -15, now I could actually write the equation in y equals mx plus b. Y equals, my m value is 4, x plus b is going to be a -15 at the very end. This is my slope-intercept form equation. Slope-intercept. That's my slope-intercept form equation. Why do they call it slope-intercept? Because when it's in this form, you could see your slope and you could see your y-intercept. Any questions? Is there an easier way to write the equation in slope-intercept form when they give you a point and a slope? Heck yeah. Okay, and by the way, y equals mx plus b, that's all about algebra 1. Right now, today, algebra 2, we're going to focus more in on this new form. This is called point-slope form. Point-slope form, okay? Now, point-slope form is called point-slope form because when it's in this form, when it's organized like this, you'll be able to see your point, which is a coordinate, and also your slope, which is the m value, just like before. Okay, now your point is going to be the coordinate x1, y1. So the point is going to be located right here and right there. And the slope, like always, is the m value that's in front of the parentheses. Okay, so check it out. By the way, before I even start with this, point-slope form is almost exactly like slope-intercept. Look, slope-intercept was y equals mx plus b. Right here you got the y's. Instead of y equals, you have y's equaling, the difference of those y's equaling. Instead of mx, it's m and then times x's, where you're subtracting, but there is no plus b. So we need to memorize this form, point-slope form, okay? How do we apply this form? Well, I would always start by writing y minus y1 equals m parenthesis x minus x1. Now you're probably thinking, what? He didn't write everything that he said. He left blank spots. This is how I always apply it. I always rewrite it with blank spots. Now, just to make it pop out at you, I am going to write it with different colors. Y minus y1 equals the slope m times parentheses x minus x1. Okay? That's my point-slope form. That's what we need to memorize. So let's write it on each problem that we do. That way we memorize it, right? The more we write it, the quicker we memorize it. So again, I'm going to rewrite it with blank spots. Y minus y1 equals m parenthesis x minus x1. Now I'm leaving them with blank spots because I'm going to plug in my x1 and y1 from my coordinate. Again, my coordinate x1 is 6, y1 is 9. So y minus y1, that's going to be y minus 9, equals the m value. The m value is 4. M value is 4. Parenthesis x minus x1. What's my x1 value? 6. Boom. Ladies and gentlemen, this is my equation that's in point-slope form. Wasn't that a heck of a lot easier than doing all this? So point-slope form is amazing. All you got to do is memorize what that form is. Y minus y1 equals m parentheses x minus x1. Now, what if I specifically told you to write your line that passes through this coordinate, this point, and this slope, and has a slope, but write it in slope-intercept form? Well, you could do point-slope form and then just manipulate it to make it back to y equals mx plus b. And what you have to remember is that y equals mx plus b doesn't have these parentheses. So let me demonstrate how I'm going to change this back to this. If I don't want these parentheses, what could I do? Distribute. Take that 4 and distribute it to both terms. So 4 times x is 4x. 4 times minus 6 is minus 24. Bring down the equal sign. Bring down the 9, the minus, and the y. And of course, y equals mx plus b is just y equals, not y minus 9 equals. So you don't want that minus 9. Get that 9 over to the other side, and you will have y equaling 4x minus 15. You see how it's the same exact equation as what we did up here? So when they give you a point and a slope, yes, you could stick with y equals mx plus b, plug in your x and your y and your m to be able to solve for b, and then use your y equals mx plus b to write your equation. Or you could take your point and your slope and plug it directly into point-slope form, getting you an instant equation. And if you still wanted to modify it back to slope-intercept, it's really easy. It's just distributing and then moving this value to the other side. Okay, this is a pretty long video. I'm sorry. We have some examples right here. Write the equation of the line that passes through 3, 4 and has a slope of 1/2. If they don't tell you what form, well then what's the easiest form to write it in? Point slope. Once again, let's all write down point slope, and let's actually write down the form y minus y1 equals m parenthesis x minus x1. And as I say, I leave blank spots. I want to show the different colors. Y minus y1 equals m times parentheses x minus x1. But then again, when I apply the point slope form, when I use it, I actually write what's in black only. I leave the blank spots. I go y minus y1 equals m parentheses x minus x1. That's how I always set it up. And then I simply plug in my x1, y1, and then I plug in my m right in there, and I'm done. So y minus what? 4 equals what? 1/2 parentheses x minus what? 3. Ta-da! Done. The equation is written. That is the line that has the slope of 1/2 and passes through the point 3, 4. Now, just for funsies here, what if they would have asked, write this equation in slope-intercept form? Okay, use point-slope form to get it down on paper, and then after that, just manipulate it, right? So what would I have to do to manipulate this to y equals mx plus b? If I wanted it to look like this, without parentheses, what would I have to do? Distribute. Now this one's going to be kind of rough because we have fractions, but whatever. Let's distribute 1/2 times x, it's 1/2 x. 1/2 times -3, that's -3/2. And then we could bring down the equals, the y and the -4, y minus 4. Sorry, it's pretty ugly. Now let's say you're really confused with the fractions. You hate fractions. What could you do to this as you're manipulating it? You could multiply it all by 2 if you wanted to get rid of the fractions temporarily, but it'll come back at the end. But it's totally up to you if you want to deal with the fractions or get rid of the fractions. If you have the Casio, it could do the fractions for you. But let's say you didn't have a calculator and you wanted to just get rid of all fractions. You could multiply everything by 2, and you would have 2y minus 8 equals 1x minus 3. And then you could worry about getting y by itself. So you would go plus 8 plus 8. You'd have a new equation that reads 2y equals x plus 5. Yay? And then my final step would be to divide everything by 2. Divide by 2, divide by 2, divide by 2. And you get y equals 1/2 x plus 5/2. That's a really ugly slope-intercept form equation, but it is that. It's the same equation, just with a different form. It looks different, but it actually produces the same line. Okay, so that was probably a bad example to convert from point slope to slope-intercept. Anyway, how about this example? This one's interesting. They want you to write an equation. Yes, they give you 2 points. They don't give you a slope. And either point slope form or slope intercept form, you need a slope. And you don't have a slope, they give you 2 points. Yesterday, we did the slope formula. Hopefully you remember. M equals y2 minus y1 divided by x2 minus x1. So your x and your y, this is your first coordinate. This is your x and your y from your second coordinate. Let's plug in our values. Do the division and the subtractions first. y2 is 6, y1 is -6, x2 is 4, x1 is -6. I'm sorry, -2. And of course, we change the minus to plus, and we end up with a 12 over 6, which is what? 2. So far, we have the m value of 2. Now, in order to write it in slope-intercept form or point-slope form, you need the m value. We have the m value now. So what form would be best? To do slope-intercept, where you need an m and a b, or point-slope form, where you need a point and a slope? Point-slope form. You have a point, you have a slope, you might as well write it in point-slope form. Okay, so from here, let's write it in point-slope form. Again, point-slope is y minus y1 equals m, which is 2, parenthesis x minus x1. Well, I probably shouldn't have plugged in the 2 yet. Yeah, let me change that back to an m, just to show the complete form, since we're getting comfortable with it. All right, so now let's actually plug in that first point. Y minus blank spot equals blank spot times parenthesis x minus blank spot. So what's the y1 value? -6. What's the m value?
2.
What's the x1 value?
-2.
Thank you very much. So from here, all you have to do is change the signs to plus positive, and we have our equation in point-slope form. So our equation in point-slope form is y plus 6 equals 2 parentheses x plus 2. That's point-slope. Point-slope. Now, if the instructions said write it in slope-intercept, then you could just manipulate it, change the way it looks. Y equals mx plus b does not have parentheses, so if you don't want these parentheses, what do? Distribute. So let's distribute 2 times x, that's 2x, 2 times 2, that's 4. Bring down the equal sign, the y, the plus 6. The only other thing to get y by itself, to make it look like y equals mx plus b, would be to subtract 6. Subtract 6. So your final slope-intercept form equation is y equals 2x minus 2. Yay?
Yeah.
Okay. I know it's a lot. Hopefully we're down, or we're really good with y equals mx plus b, and the only thing we're actually learning is the point-slope form. So we're also going to move on to parallel lines and perpendicular lines, but we're going to do that on the next video.